Alright, we have the fourth one here. We are trying to prove that YZ is equal to WZ. So we're trying to prove that this and this are the same length. The information we get to start with is that YX is equal to WX, and you can see that that's marked already on our picture. YX equals WX. We're also told that ZX bisects angle YXW. So the big angle on top is being bisected or cut in half by ZX. So that is the line segment that cuts it in half. And when we do that, we know we're going to get, and we'll mark this in different color because we do have to mark it as a step, that this angle is getting cut in half into two equal pieces. Looking at what I have in my picture, I see that I have equal sides, I have equal angles, and I have a shared side in the middle. So I'm going to double mark that already. And I already am going to know that I have the ability to prove that these two triangles are congruent to one another. The question is kind of like before, does knowing that those two triangles are congruent really help us? Well, let's think through our options at this point. This one's kind of a tricky one. I can see that we have, if we were to do that by CPCTC, we would get the fact that these sides are equal to one another. I also know that this side right here, by reflexive property, is going to be equal to itself. So that would give me side and side. It wouldn't give me that last side. Let's see if we can get any angles out of this. So is there any angles we get for free? We can get vertical angles out of here and here. Zoom in a little bit. We can get vertical angles here and here. We can also get vertical angles here and here. Now, at first it doesn't seem like that helps us, because knowing that the angles across from each other are the same isn't really helpful. But the convenient thing is that we happen to know that these angles by CPCTC are going to be equal to each other, and by substitution then we would be able to prove that these are going to be equal to each other as well. So that would give us a side, an angle, and a side, and by SAS we can prove this whole big triangle is congruent to this big triangle, and then break it apart, and we're going to get this one and this one. If you're confused a little bit, then you are human, so let's come along for the ride and see if we can break that down a little bit more, one step at a time. First thing, always the easy step, we'll take our given. So by our given, we are going to get that YX equals WX, and that ZX bisects angle YXW. So that's all by our given. Next thing, we took that definition of the bisector, because we were given a bisector, so we took the definition of the bisector and we used it to say that YXZ, angle YXZ, is equal to angle WXZ. So we have those two angles equal by the definition of the bisector. We also said, we also said early on that the clear this out, that the side in the middle, the X to O in the middle, is going to be equal to itself by reflexive property. So XO equals XO by reflexive. And with that, we now have enough information for a side, an angle, and a side. And we get the same thing over here, side, angle, side. So we can prove by SAS that these two triangles up here are equal. I'm going to clear out some stuff to make it readable again. WXO, triangle WXO, is congruent to YXO. So those two triangles are congruent to each other. And we did that by saying side, angle, side. So we have our two congruent triangles. Now, the things that we said we are going to need based on our plan for later, we need this angle here being equal. We also need this side and this side here. So the brown marked angles and the pink marked sides we're going to need by CPCTC. We can write that all in one step since it's the same reason. So a CPCTC, we're going to get some angles. So we're going to say angle YOX, angle YOX is equal to angle WOX. We also are going to get side YO is equal to side WO. And if you're not sure from looking at the picture that that's something you can do, you can look at the way you wrote it up here. W and O would be first and third letter, Y and O would be first and third letter. So those sides are definitely okay. And the angle O here, angle O is at the end of both. And if you even wanted to check for the three-letter example, XOW, XOW, YOX, reading backwards, YOX. So reading them both backwards, you can get all of that information. So moving on, we got that all from breaking apart that triangle. And now we're focused on the lower triangles, and we're trying to prove those equal. So we're going to use our vertical angles. That's the purple and the blue that we marked in there. The vertical angles before we do some substitution. And then we're going to have our OX be reflexive as a side. So let's write that OX side first, a little easier. Or OZ, excuse me. So OZ equals OZ by reflexive. And then we're going to do our vertical angles. I always like to write my reason first because it just helps me make sense of where things are coming from. But we have the angles directly across from each other here, XOW, YOZ. XOW equals YOZ. We also have XOY, WOZ. So XOY, WOZ. Had to take a quick timeout to make some room there. Now we're going to do our substitution step because we don't care about the fact that these angles across from each other are equal. We really want to get to the fact that this angle and this angle are equal. That's where we want to get because that's going to give us SAS. So I'm going to substitute my angles from above. We know these angles are equal. We know these angles are equal. We know these angles are equal. So let's plug these into each other. XOY and YOX are the same thing. You can write an angle, three-letter angle backwards as long as you completely flip it and O is still in the middle. That is still the same. So these two are exactly the same angle. And let's match up our other ones here. WOX or XOW, these are going to be the same. So by substituting in, we can plug in WOZ is equal to YOZ. And that's going to give us WOZ, YOZ. Those two inner angles is what we want. And that's by substitution. Remember, with substitution, you can only substitute from things you've previously written above. So if it's not written somewhere up here, you can't use substitution with it. So final steps now, we have the triangles are going to be congruent finally by SAS. Triangle YOZ congruent to triangle WOZ. And then our last step by CPCTC, we finally get what we wanted, which is that YZ equals WZ. First letter, third letter equals first letter, third letter. And that is what we tried to prove. So that was a long and very fun one, but definitely challenging.